morning, dear friends. I am Dr. Yagya Dutta Dwivedi. I feel immense pleasure to welcome you all here for my course Flight Mechanics. I am in the last phase of my course. Before this course, I have completed all my module 1, that is Introduction to Flight Mechanics, in which I have covered the standard atmosphere, different layers, different types of airspeed like true airspeed, equivalent airspeed, indicated airspeed, calibrated airspeed. Then we have find out the different forces like lift, drag polar. Then we have reached to the second module, that is the cruise flight. In the cruise flight, we have learned the equations of motion, thrust required, power required, thrust available, power available, range, endurance, range for different parameters when angle of attack is changing, when altitude is changing, when velocity is changing. There are 3 different parameters which we have already done. Then we have started module 3, which is the climb performance. In the climb performance, rate of climb, maximum climb angle, descent angle, power required for the climb, thrust required for the climb. These all things we have learned, we have done. In module 4, we have started with maneuvering flight. In that, first unaccelerated or coordinated turn. In that, we have seen that how much radius is required in the same plane if aircraft is turning, no vertical motion. How much angle it can turn, how much time it will take. Then we have gone to the vertical maneuver when aircraft is pulling like this. We have find out the load factor of that. We have also seen the how much radius it can turn, minimum radius, minimum maneuvering velocity, load factor, stall zone, structural failure, Venn diagram, never exceed speed. Then in the last module, we have discussed about landing and the takeoff performance. In that, we have already how much ground distance is required, how much ground roll is required, then transition, then climb. For landing approach, then flare, then ground speed, ground distance. These all things we have done. Today, we are going to discuss about definition and some terminology related to the module 4, that is aircraft maneuver performance. As just now I have discussed, in this module, our aircraft is not steady state, it is having accelerated flight. Before that, all the 3 units, we have seen that aircraft is going as an accelerated flight. I am Dr. Yagya Dutta Dwivedi, professor from Institute of Aeronautical Engineering. Today, I am going to discuss about definition and the terminology of maneuvering performance, load factor, Venn diagram, boundaries of flight envelope, and so on. So, definition and the terminology of maneuvering performance. This is our topic for the day. So, we will discuss about define the maneuver. So, what is a maneuver? Maneuver is an essential part of the mission profile. Aircraft need to turn, pitch and change its airspeed to carry out its mission. Maneuvering flight. An aircraft can be said to be in maneuvering flight when its flight path is in the continuous change in state and in which there is an inertial force due to the acceleration. So in maneuvering flight, acceleration is essential. And in this, one inertial force will be acting. Define the linear acceleration. The linear acceleration arises from an imbalance of the forces in the direction of the flight. This may be due to the excess of the thrust or the drag. So if you see here, this is the aircraft, this is here drag, and this is here thrust. If thrust is greater than the drag, aircraft will accelerate. This is the acceleration. And if T is less than drag, aircraft will start going back. This is called deceleration. So it is happening due to the balance of the forces. If forces are the balance, there will not be any acceleration. If the forces are not balanced, in which side force is more, that side object will try to move, and then acceleration will be generated. Need for linear acceleration. The linear acceleration is employed to control the airspeed in which thrust is increased or decreased. So if you increase the thrust or the drag, your aircraft will increase or the decrease. If you increase T, as much you increase, velocity will increase. So dV by dt is increased. So it is an acceleration. Define maneuver envelope. The plot between load factor and indicated airspeed is maneuver envelope. It gives the structural limits of the airplane. So I will just discuss about this. What is that envelope? Every pilot has to fly the aircraft in that zone. So I will draw the VN diagram. This is the negative, this is the positive load factor, this is the negative load factor. Here, this is the another limit. Then I will go with some so if you see here, from here to here and from here to here, this is your VS, this is your VM, maneuvering point, maneuvering velocity, or V star, it is also called the V star, and this is called the maneuvering point. This area is the stall area, it is aerodynamic area. This blue color is aerodynamic area and red color is structural failure. Structural failure, and here is the high pressure zone. Here also structural failure. This is here aerodynamic zone, and this is called the flight envelope or maneuvering envelope, when this area is best for the maneuvering of the aircraft. This is called the, all pilot is supposed to fly the aircraft in this zone. So this I am just putting like this green. So this area is called the flight envelope. Every pilot is told to fly the aircraft. This is called flight envelope. Structural boundary. So these are called the structural boundary. Structural boundaries. So in this, your aircraft is going to damage in this area, and a structural failure may happen. There are positive and the negative structural boundaries first occurs for positive load factor and later due to the negative load factor. So these are the negative N and this is the positive N. Airspeed boundaries on VN diagram. The airspeed limits which are defined as equivalent airspeed are determined by the stall boundary. So I have shown you just now here. These are the airspeed boundaries. It is happening due to the stall for the positive and for the negative load factor like this. So this zone is your speed boundaries. Low speed boundary, the stalling speed at which the aircraft can maintain steady state flight in a specified configuration forms a low speed boundary. So these are the low speed. This is for the negative load factor and this is for the positive load factor. The stalling speed, and this is here is Vs. So the stalling speed at which the aircraft can maintain steady state flight in a specified configuration forms low speed boundary. Stall buffet. The warning of the impending stall is provided solely by aerodynamic buffet. So the warning of the impending stall is provided solely by the aerodynamic buffet. Pilot will experience some abnormal sound, some sound will come like this, start vibrating. So this buffet, stall buffet will be observed when the aircraft is about to reach the stall zone. High speed boundary. The high speed boundary is determined by the maximum structural dynamic pressure loading. So if you see here, we have made like this, this limit. This is the VNE, never exceed speed. Here due to the dynamic pressure will be very high. Dynamic pressure very high and structural failures may happen. Longitudinal maneuver. The longitudinal maneuver is the result of an imbalance of thrust and the drag, which results in either a linear acceleration or a steady rate of climb. Specific excess power. The product of the excess thrust and the true air speed per weight is known as the specific thrust power. So product of the excess thrust. So T available minus T required into velocity. And this velocity is true air speed. Per unit weight is known as a specific. So if you divide it by the mass or W, then it is a TR minus TA minus TR V by W. We can write is a PA minus PR by W. Okay. So this is the specific thrust, excess thrust. Use of excess power. Excess power can be used to increase potential energy, that is the climb, or to increase kinetic energy, acceleration of the aircraft. So if you have the excess power, means if you have PA minus PR is greater than 1, then what will happen? You have the potential energy. It means start climbing like this, or increase kinetic energy. Increase kinetic energy means speed is increased. Speed is increased. V is increased. So if you have PA and excess power, you have either it will start climbing, potential means height will increase, or speed will increase. So any of this energy will increase if you have the excess power. The lateral maneuver. The lateral maneuver is also known as the level turn. So what is the meaning of? This is the XY plane, and if your aircraft is turning like this, in the same XY plane, it is called the lateral maneuver. There is no maneuver in the vertical plane. Only in the horizontal plane, your aircraft is moving like this, like this, like this. This type of maneuver, it is called the coordinated turn. Steady coordinated turn. In this, the maneuvering which is happening, turning of the aircraft or your acceleration is changing every time, that is called the lateral maneuver. Stall boundary, the maximum angle of attack at which the aircraft can be flown in a steady flight is limited by the stall or the stall buffet boundary. So, if you see that here, Venn diagram, and this is the stall boundary. These two lines are the stall boundary. So, aircraft should not fly less than this. Otherwise, aircraft will be the problem and will start sinking down. Define pull-up maneuver. The pull-up maneuver is a coordinated maneuver in the vertical or pitching plane with no rate of turn or side slip. In the vertical plane, if your aircraft is here, this is here radius, you're pulling like this. So here, this type of maneuver, when it is in the vertical plane like this, it is called the vertical maneuver. The pull-up maneuver is a coordinated maneuver in the vertical or the pitching plane with no rate of turn or the side slip. Means there is no turning, only in the Z plane it is moving. Condition for pull-up maneuver, the load factor in the loop is not uniform and will vary with airspeed and flight path angle as the aircraft progress around the loop. So in this type of condition, the pull-up maneuver, the load factor in the loop is not uniform. It will vary for the different. If it is here 1, 2, 3 and 4. Every place the N will be changing. Next is most sustained turn. The most sustained turn that the aircraft will require to carry out in normal operation and will be flown at a speed commensurate with flight safety. So, the most sustained turn that the aircraft will require to carry out in normal operations and will be flown at a speed commensurate with flight safety. Define pop-up maneuver. Pop-up maneuver from low-level flight that would demand a higher rate of pitch than the simple gradient changing maneuver. So if you change your pitch angle much more than the required in this, so pitch angle, that is theta you have to change more than the required. Pop-up maneuver from low level flight, you are here at the low level flight, that would demand a higher rate of pitch than a simple gradient changing maneuver. So more theta is required, that is called pop-up maneuver. Define high G turn maneuver. Define high G turn maneuver. The high G turn is a maneuver that allows the player to make a sharper turn than the normal. While the aircraft will lose a substantial amount of speed, high G turn can be used to effectively evade incoming missile or enemy aircraft or to continue pursuing an advanced enemy. So, if the aircraft is equipped with that much power, engine power is very high, aircraft can go with a very high load factor, that is called high G turn, is a maneuver that allows the player to make a sharper turn, very sharp turn it will make. Because aircraft is deemed to be good if it can do very sharp turn. Radius of the turn should be very less. While the aircraft will lose a substantial amount of speed, The high G turn can be used effectively evade incoming missile or enemy aircraft or to continue pursuing and advance enemy. Here we will have some define VN diagram. Whatever I have discussed just now, it is now we will discuss the VN diagram. So here, this is the 1, this is the 2, this is the 3, this is the 4, and this is the 5. So in this VN diagram, we have 5 lines. 5 lines. 2 lines are curved. 3 lines are straight. So this line are very important because 0 to this one line, it is a aerodynamic line, and this is in the stall zone here. If we are here in this area, it is not safe. And here also, this is also aerodynamic zone. Aerodynamic zone. Here stall will happen. So you have to fly in between. If you are less than this, aerodynamic problem will exist. And if you are in the above 3 here, structural damage here also and here also. This all are the structural damage. This is the speed. It is called VNE, maximum speed, never exceed speed. If you are going above this speed, your dynamic pressure will be high. Dynamic pressure will be high, so you are not going to get that much. So now, curve line in VN diagram. If you see here 0 to 1 or 0 to 2, these 2 lines are here 0 to 1, 0 to 2, 2 curved line. These lines represents aerodynamic boundaries, and stall will happen. Stall will happen. 0 to 1, 0 to 2. If you are less than that, stall will take place. And straight line in VN diagram we have here 1 to 2, 3, 4 and 5, just you can write. So 2 to 3, 3 to 4 and 4 to 5. We have the 3 lines. These lines 2 to 3 is structural damage zone. 4 to 5 is high velocity dynamic pressure zone, and 4 to 5 is again structural damage. This is the positive load factor. This is the negative load factor. Here it is due to the VNE. Define maneuvering point. The point on the configuration where the location of the CG would result in the control force required per G maneuver to be equal to 0. So per unit maneuver, the CG location is called the maneuvering point. Define maneuver velocity. The maneuvering speed of an aircraft is an airspeed limitation selected by the designer of the aircraft at speed close to and faster than the maneuvering speed, full deflection of any flight control surface should not be attempted because of the risk of the damage to the aircraft structure. So if we are flying aircraft at the maneuvering speed, and if we go beyond this speed, we cannot use all the control in the full control. If you are using, your aircraft is going to be damaged. There are some chances of failure of the aircraft going to happen. Define maneuvering stability. Maneuvering stability is related to static longitudinal stability. It is a measure of the longitudinal stability tendency of the airplane in other than 1G flight, and it accounts for the effects of pitch rate aerodynamic damping during maneuvering as in the recovery from the pitch upset. Define minimum maneuvering speed. Minimum maneuvering speed, that is FCTM. Minimum maneuvering speed is the slowest speed that provides full maneuver capability of 1.3 G or 40 degree of the bank, 25 degree of the bank and 15 degree overshoot to stick shaker. Define VM0. VM0 part is the aviation term indicated maximum operating velocity, that is MO means operating velocity, maximum operating velocity, and it is an attitude and a reflection of our approach to who we are, what we do, and most importantly how to do it. So it is a maximum operating velocity of the aircraft. What is the difference between VA and the VO? VA stands for the design maneuvering speed and VO is a maximum operating maneuvering speed. VA is a limit factor, but VO is less than that because we should not cross VO. Otherwise, if we cross, we will go to the VA and your damaging may happen. Part 25, pilot use VA to describe both design maneuver speed and maximum operational maneuvering speed. Define VO mean in drones. One way drone pilot mitigate risk is by designing a visual observer V0 to assist in visual observation during UAS operation. Though the FAA does not require the use of visual observer, they do require that the remote pilot in command RPIC maintain visual sight of the aircraft at all times during the flight. Define FPV for a normal drone. The FPV for normal drone. The major difference between FPV and the regular drone is the perspective with which you fly them. Regular drones are operated by handheld control that you can attach your phone to as a viewfinder. FPV drones are flown with the pilot wearing a set of goggles which let them see what the drone camera is seeing. What is PWM drone? PWM means pulse width modulation and is used pulse timing to determine the speed at which the motor should rotate. Almost all ESCs support the PWM protocol, which is how radio receives communicated with ESC and servos long before the advent of the drone. Define VMC, VMO and the The VMC means minimum control speed with a critical engine inoperative. VMC is a minimum control speed with the critical engine inoperative. VMO means maximum operating speed. VMU means it is VMU. VMU means minimum unstick speed. VNE means never exceed speed. VNO means maximum structural cruising speed. So here we have VMO, maximum operating speed. VMU, minimum unstick speed. VNE, never exceed speed. VNO, maximum structural cruising speed. VMC, minimum control speed. So these are the few speeds which are described here. Define VS1 speed. The stalling speed or the minimum steady flight speed obtained in a specified configuration. For most airplane, this is the power of stall speed at the maximum takeoff weight in the clean configuration. So the stalling speed or the minimum steady flight speed obtained in a specified configuration for most airplane, this is the power of stall speed at the maximum takeoff weight in the clean configuration. What are four basic flight maneuver? The four fundamental straight and the level flight, turns, climb and the descents are the principal maneuver that controls the airplane through the sixth motion of the flight. What are the different types of flight movement? Glide flight, flapping flight, bounding flight, hovering, takeoff and the landing. These are the some flight movements of the aircraft. Next topic, I am going to discuss about definition and the terminology of the takeoff and the landing, safety requirement, flight planning. These are the references: Anderson J.D. Jr. Aircraft Performance and the Design, International Edition, McGraw-Hill's first edition, 1999. Isel by M.E. Aircraft Performance Theory and Practice, AIA Education Series, AIA 2. Any questions, you are welcome to ask. My email ID is yd dwivedi @gmail.com. Please do like and subscribe this channel. Also put the bell icon. Do comment if you feel anywhere it is not suitable or it is not correct. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.